Good morning, everyone. I hope you all are doing well. So, this video is going to be about Unit 4, actually, Unit 4A, which is selection. And here we will talk about basically two things: flowcharts and how to add selection in your code. Now, in the previous units, what we had studied was that um, you when you create algorithms, one way of demonstrating or one way of showcasing that algorithm is by drawing flowcharts. Now, flowcharts explain or kind of make you understand how the program should work at the end, or what are the different steps that need to be taken in order to create a program. Now, when we create a flowchart, there are a few, let's say, shapes that you need to know, and you need to know about when we use those shapes. So I'll quickly show you the shapes first, and then we will talk about how to build a flowcharts. Now, the flowchart basically has four shapes that we are going to use. One of them is the terminator, this shape here, and this is basically used for start. My apologies for the writing, it's just difficult to write with the mouse. Start or end. Okay, these shapes, the terminator shape is basically used for the start and the end of a flowchart. The data block, which is this one here, it basically is used for showing or demonstrating what are the different variables. That's a V, okay? Variables, and what are the different objects that you are going to use in your code. So variables and objects. So for example, you have you have to create a program where you read the user's age, and then based on their age you do certain actions, like you perform certain actions. Now, in that case, you would use one scanner object and one variable to store age, because you need a scanner object to read the input, and then you have to store that input somewhere. So in order to store that, you would use age variable, which could be integer, right? So that the data block is used to represent the variables or the data type, variables or the objects that are going to be used in the program. For the process, the process block is used for instructions. So for example, this could be prompt the user, or print something out for user, or calculate something. So one line of usually one to two lines of code that will represent a certain instruction need to be used in the process shape, which is basically a rectangle. The final one is basically decision, and decision allows you to choose between, like, to choose between two actions depending on the condition, depending on a specific condition. So here, whatever we write here in this shape is usually a question, and the answer to that question needs to be true or false, and based on that answer we choose a different path in the program. So this shape usually has a true branch, we call it branch, but you can, like, it's a side for the shape. Okay, so a true branch and then a false branch. I'll just write F for false. So if whatever you've written here turns out to be true, you follow one sequence of action, and if it's false, you follow another sequence of action. Now, this could be anything. For example, it could be a password that the user gave you. You're checking if that password is correct or not. If the password is correct, you will probably allow them to move on to the next screen. Otherwise, you will just tell them, your password is incorrect, please try again. So those are the four different um, shapes that are used in a flowchart. The first one is terminator, start or end, data block, variables or objects, process, which is basically instructions, and then decision, which is always a question. You always write it as a question, which has two sides, and then depending on the answer, you follow one of the branches. Now, if we had to um, draw a flow chart for, let's say, a user who goes to an ATM machine and they insert their card, now what will happen after that? So you can represent that as a flow chart as well. The first thing that would happen is the user would insert the card, the user would then enter the PIN number, and then the system will decide if the PIN number is correct or not. If the PIN number was correct, it would show the services and the user will choose from the available services. If it was incorrect, in that case, we display the message, you have entered an incorrect PIN. And in most of the cases, in most of the realistic cases, it would eventually go back to go back to requesting the PIN again. Okay, so that is one way of showing how we can basically represent a logic or an algorithm in the form of a flow or a flow chart. Now, if you had to create a flow chart for this, it would have been this way. You would actually have a start, because every flow chart, like we said, needs to have a start. So start, and then similarly you would have an end. Okay, and everything between the start and the end should be connected. If something is not connected, that means it's an incomplete flowchart. Now, right after the start or the terminator, in the beginning, you need to add the data block. And in the data block, you will represent all the variables and objects that you require. So for example, we need to read the password or the PIN from the user, so we need a scanner object. I'm just writing it. I'm not writing the whole thing. I will just shorten it. So scanner object, and then O for object, and then you need integer PIN to store the PIN. PIN is usually a 4-digit number, right? So you can use an integer for that. And so this represents our object and variable. Now we need to always connect the shapes. So you connect from start to the data block, and then you prompt the user for the PIN. So you have a process or action block, and then you would write prompt. Prompt for PIN. Okay. Now, once you have the PIN, you need to decide whether the PIN, not you, but the system needs to decide whether the PIN is correct or not. So that's where we use the decision. So you have the diamond shape for decision, and whatever we write in the diamond shape is always a question. So here you would write, is PIN correct? Is PIN correct? I'll just put a check mark for that, and then you need to have a question mark. Now in the case when the PIN is correct, you do something which is for the true side, and on the other side it would be false, where you do something else in case you have, let's say, the PIN is not correct. All right, now you have one process here to do when the PIN is correct, and another process here to do when the PIN is incorrect. So let's say you show the menu if the pin was correct, so the user can proceed. And if it was false, in that case you print some error, and maybe in some cases allow them to try again, but here we'll just end after the error. And then finally you can move it to the end or connect it to the end. That would be a flow chart for this flow. Okay, it's a little bit incomplete. If you have to create a flow chart, it should look like this. You need to have start, you need to have end, and everything needs to be connected. Okay, so that's about the flow chart. And in one of the previous like units, you have seen a similar flow chart. You've seen a flow chart where a lamp wasn't working, and we're trying to figure out what's the reason, or we're trying to solve that problem. And again, you would notice there was a start, there was an end, and everything was connected. You had two decisions here, and all the decisions are written as a question. And then you have a branch for true, a branch for false, which is yes or no. All right, now that is the flowchart. Again, you can come up with different examples to create flowchart on your own. One such problem could be deciding what clothes to wear depending on the weather outside. So you would check the weather first, and you would see, okay, is it rainy? Maybe you need to get an umbrella. If it's windy, maybe you need a sweater or a jacket. If it's sunny, then probably you don't need any of those. So again, you can describe all of that as a flowchart from start to finish, or start to end, and have the different decisions and actions accordingly. Now we're talking about the diamond shape, or the selection or decision. It has many names. But how do we create these? What is required for these conditions? Like, how do we represent this in code? For this, we need to have a mix of conditional and logical operators. Okay, now there are all of these operators available, which are listed here: equality, inequality, comparison, and, or, not. All of these have a specific job, and you can use these to create conditions. Such conditions that will always give you an answer that can either be true or false. Okay, because conditions should also always have true or false, which is why we always have a branch for true and for false. If the condition does not give you if the condition doesn't, like, if whatever condition you've created, if it doesn't result in true or false, in that case it is not a proper condition. Okay, so what are these conditions? Now we'll look at them one by one. You have one that is called equality, and bear in mind, whatever condition you create, it has to have three parts. Okay, there should be something on the left side, something in the middle, and then something on the right side. Okay, for example, if I want to use equality operator, the operator always goes in the middle, so I would write it as equal to, but at the same time I need something on the left and I need something on the right, because equality operator allows me to check if the value that is present on the left is it the same as the value present on the right side. For instance, if I write 7 is equal to 7, in this case, what happens is the equality operator looks at the value 7 and checks, which is on the left side, and checks if it is the same value that is present on the right. If it is, then this will give you true. Okay, but let's assume that I make this 17. Now this is 17. Okay, what equality operator now does is, again, it does the same thing. It checks the value on the left, is it the same as the value on the right. In this case, 7 is not the same as 17, so the answer you would get for this situation is false. Okay, so this is one condition that you can create. Now, one second. Okay. Now, let's talk about inequality. Inequality again is the same, which means you need to have something on the left, you need to have something in the middle, and you need to have something on the right. Okay. In the middle, you have the operator, which is not. This stands for not. Exclamation in programming stands for not. And then you have the equal to. This means you're checking this operator. What it means is you're checking if the value on the left, if it is not same as the value on the right, it will give you true. But if the value on the left and the value on the right are the same, it will give you false. Okay, so for instance, sorry, for instance, if I write 7 not equal to 7, we know 7 and 7 are the same. So if I try to say 7 is not equal to 7, that is wrong. So in this case, it is false. But then again, if I change this to 17, 17 not equal to 7, that is correct. 17 is not equal to 7. So in this case, it will give you correct, which is true. Okay, similarly, we have another operator which is used for comparison. Okay, so for instance, you want to check similarly, like you have a left side and you have a right side, but then you are going to check, is 17 greater than, let's say, is 17 greater than 73? In this case, 17 is not, we know 17 is not greater than 73. So the answer for this is false. But if I say 170, is it greater than 73? Then in that case, the answer is correct. Similarly, we have the other comparison operators, which is less than or equal to, greater than or equal to, all of that. So in this case, we also have, let's say, 73 is greater than or equal to 73. Now 73 is not greater than 73, but it is at least equal to 73. So in this case, you will get true. So when you have two of these comparison operators joined together, either of the condition can be true to make the whole condition true. So for example, 73 is not greater than 73, but it is equal to 73. So this will work. And you have similarly 73, I can write the same thing, 73 less than or equal to 73, which again, 73 is not less than 73, but it is equal to. So in this case also, it will give you true. So these are some of the conditions that you can create, which are nothing but mathematical equations. You must have seen them in math. They're very similar, and you can, like, whenever you write these, you will either get true or false. Now there's one, there are two more operators that allow you to create conditions, which is and or. What these two do is, for example, if I write, now let's try to introduce variables. So when I write int num is equal to, let's say, 7 semicolon, and then I write num it is greater than or equal to 0, and I have another condition, num is less than or equal to 10. So now I have two conditions, one here and then one here. I can join these two conditions using either and or the or operator. If I write and what that means is, for instance, let's say we write and. What happens is the first condition gets checked, and then the second condition gets checked. And based on the result of these two conditions, and will give the final result. So for example, here num, which is the value 7, if it is greater than or equal to 0, so 7 is greater than 0, so this becomes true. Then num is less than or equal to 10, which is 7 is less than or equal to 10. So in that case, this condition becomes true. So and will give you the final result, which is if both the conditions are true, so in this case both the conditions are true, and will return true. If one of the conditions was false, so for example, I make this 17. Now 17 is not less than 10, so this condition becomes false, and if either one of the condition is false, and operator will give you false at the end. Okay, now just remember this, for the AND operator, both the conditions need to be correct, and these operators AND and OR can only join two conditions together. So the first condition and the second condition, when both of them are true, only then AND returns true, otherwise it returns false. Okay, now the same thing, for instance, if I use seven, or we can take the other one as well. Let's say 17, num is 17, and we're checking num is greater than 0. It is. 17 is greater than 0. Let's combine them using the OR operator. And num, which is 17, is less than 10. So in both of, so this part is true because 17 is greater than 0. But 17 is not less than or equal to 10, so this part is false. With the OR operator, what happens is if either of the two conditions are correct, the final condition will be correct. Meaning if either of the two conditions are true, the final condition is true. The only time OR operator gives you a false is when both of the conditions are false. Okay, but in this case, again, if in this case the one of the conditions is true, so in here it will return true. Okay, this is similar to when someone says for your exam you need to bring paper and calculator. So that when I say paper and calculator, you have to bring both. You have to bring paper and a calculator. But when I say you have to bring you can bring a paper or a calculator, then you can bring either one of the two. That's the difference. And for and, all the conditions should be true. For or, either of the condition can be true. And finally, there is not, which is nothing but the opposite. So for example, if I write something like this, num, this is u, num is equal, or let's say greater than or equal to 0, and we're still assuming num is 17. So num is greater than or equal to 0. This is true. 17 is greater than 0. But if I put a not outside, what it does is it changes, or it makes the result opposite. What does that mean? If it is true, it will make it false. If this was false, then it will make it true. So it just gives you the opposite result. So if it's true, it makes it false. If it's false, it makes it true. Now, the reason I've spent so much time explaining this is because these are important. This is the building blocks of actually writing code, because you need to understand how to build conditions so that you can write them in your code. And majority of your code depends on selection or conditions. Okay, we've spoken about this. Now, this is just another example, but what I want you to know from here is this part. This is important. if statement. If statements are basically the building blocks. Like this is how you can add selection to your code using if statement. Okay, and there are three kinds: one-way selection, two-way selection, and multiple selection, which includes cascaded if and nested if. Okay, now we'll start with the first one, which is one-way selection, and this is how it's written. You need to write if, the keyword if, and then have two round brackets and then expression within. This is basically that condition that we studied just now. For example, if you write num is greater than or equal to 0, okay, these conditions are basically the expressions that you need to write, and then the block of code that needs to be run in case this condition returns true. If this condition returns false, then you skip this block. You don't need to, like, the system will not have to execute it. It will just skip to the next available statement. This is the representation of one-way selection. Okay, you have one condition here, and then you have a branch for true, and then for the true you have a block of code that gets executed if the condition was true. On the false side, you don't have any block, meaning there is nothing written in the false side. So these kind of questions can come up in exam, where you have, like, you've been given a screenshot like this, and you need to guess which selection is this. Is this one-way selection, two-way selection, or multiple selection? Okay, now this is how you would write a single or one-way selection statement. You write the word if, you need to put the brackets here, the round brackets, and then your condition here. In this case, we're using the equality operator, and we're checking if the value that is stored in the num integer is it the same as the value that is stored in on the right side, which is the value 7 in this case. If num had 7, then this is the block of code that gets executed. Now notice you have parentheses or the curly brackets here. And in the code that you've written so far, you must have noticed that you put parentheses every time you create a class and every time you create a main method. A class and a main method. Now, the reason I'm trying to mention this is because every time you put these brackets or these parentheses, you do not put semicolon on the line before. So if you put a semicolon here, it will not give you any error, but the code will not work at all. So just remember, wherever you have, so for class, for main, and for if statements, you do not put semicolon when you have these curly brackets. Okay, but yeah, just remember that. Now, if the value was equal to 7, the system will print you win the prize. If the value was not equal to 7, it won't do anything because there is no other instruction. Similarly, you could have used not equal to 7 also, which is an operator, the inequality operator. And in this case, what would happen is if the number was not, like, if the number is any other number other than 7, it would print better luck next time. Okay, so that is how you can create conditions in your code. And in Flowchart, these look like this, with a diamond shape. You put a question mark here along with the phrase, the question that you want to write, which will be, is the number 7, and then you have a true side for a block, very similar to this. I shouldn't have drawn it again. It's very similar to this. Okay, now again, you can use comparison operators. This one will check, is the number greater than 10? If this is 11, it will give you true, but if this was 10, it will give you false, because 10 is not greater than 10. And in this case as well, you're checking if the number is less than, sorry, if the number is less than or equal to 0. So if the number was 0, it will work, it will give you true. If the number was, let's say, minus 10, then also it is true. But if it was, let's say, 40, then it's not true, because 40 is not less than 0. So this is another way of writing the condition. So anytime this condition is true, this statement will be printed out. Similar for this case. Now, one thing to notice is here, this is a valid way of writing an if statement, and this is also a valid way. They are the same. In this case, they are the same. And here we consider it, this part, this statement, we consider it a block statement, which is basically made up of a single statement. And then either you can have a series of statements surrounded by braces. What this really means is, if you have an if statement and the block for that if is just one line of code, in that case you can skip the braces. No need to put the braces, these braces. But if you have multiple statements that need to be written within the block that belongs to the if statement, then you need to put the braces. As a beginner, I would recommend that you always use the braces, because you can get confused if you have a lot of code to write. You can get confused if you don't put the braces. And the problem here is it never tells you, it never gives an error. It will just not work properly. So in my opinion, always use the braces, even if you have just one line of code within the block, within the braces, I mean. Now, this condition here is very, very important. You will maybe see it in multiple questions in your exam. Now, what this really means is, for example, if I take any number, any odd number, okay? If I take any odd number, for example, 5. I take 5. This is 5. Oh. Anyway, just assume this is 5. And then you divide it by 2. So 2 multiplied by 2 gives you 4. And what remains is 1. Similarly, if I take, let's say, 11, and I divide it by 2, 2 times 5 gives you 10. What remains is 1. Okay, so and if you do it with many other odd numbers, you will always get the same thing. The remainder will always be 1. Okay, so in order to check if a number is odd, what you can do is you can use the remainder operator. What this operator does, it gives you this result after division. So whatever number you have, you use the remainder operator with 2, and if the result is 1, that means the number x is odd. Okay, similarly, if I divide any even number, for example 2 and then 10, 2 times 5 is 10, and so the remainder will be 0, right? So this is a thing, this is a universal fact, you can assume it to be. Anytime you divide an odd number by 2, the remainder is 1. Anytime you divide an even number by 2, the remainder is 0. So if in the exam you have to check if a number is even or not, what you can do is just write x modulus, this is also called modulus operator, modulus or remainder operator 2. This can be any variable, whatever variable you've created. Modulus 2 is equal to 0. Okay, so either 1, if it is 1, then that means the number is odd. If it is 0, that means the number is even. So yeah, that is an important condition to remember. Now, this is exactly what I just mentioned. Just as a beginner, I would recommend always use the braces here. It will make your life easier, because you don't get an error if you don't use the braces in most cases. Okay, now if you read this code, if you try to read this code, what it tries to do is you're reading an input from the user, because you have a scanner class which is reading input, and so you read the input here, you store it in the in the variable number, and then you check if number is the same as 7. So whatever number the user gave you, is it 7? If it is, you print you win today's grand prize. Otherwise, do nothing, because there is no other code. Okay. Now the second way, so far what you've looked at is it is one-way selection. Now you have something called two-way selection, which is the else part. Okay. This works. Okay. This looks very similar to if. It just the only difference is the word is else, and there is no brackets, no condition after that. The only thing it has is the braces, similar to if. What happens is it checks if this condition is true. If the condition was true, this statement in the if block is executed. Everything else is skipped. Okay, the else part is skipped. But if this condition was false initially, this part is skipped and everything in else is executed. So that's how it's written. You have the if, the condition, block for if, and then you have else and the block for else. If this is true, this works. Okay. If this is false, this is skipped, and then this one will work. Okay. And this is the representation of two-way selection. You have a condition, you have a branch for true, you have a branch for false, and you have a block for each of them. Okay, so if the condition is true, this block works and this is skipped. But if the condition was false, which means this side was correct, then this is skipped and this one works. And then you finally go to the end. And this is how it would look like in code. You have an if statement, you're checking the same code we just looked at. You're checking if the number is 7, you print you win today's grand prize. Otherwise, if the number is any other number other than 7, then you print better luck next time. And this is the most optimal way of doing it, because if you just leave it at the previous one here, then if the user printed 10, nothing happened after that. So the user has no information about what happened next, So it's always better to have an else statement in most cases. Okay. And the same issue, you should always make sure that you're using the braces with both if and else. I don't recommend writing code without braces unless you are a professional programmer. Okay. Now, which one is correct here, depending on the braces? Now, you have to understand two things here. The first one is selection and the second one is sequence. Okay. Now, if the number was odd here, which means this is true, then X is going to be printed. And because this statement is outside of the if braces, this statement will always be executed. So it will print this also. But in the case when this condition is false, X is not printed, but because of the sequence, because computers follow each line of code sequentially, this will still be printed as odd, which is not the correct way. And this code here in B is very similar to the code in A, because you're skipping the braces, assuming that this line is the only statement connected with the if block. And again, if this was false, if the number was not odd, it will not print X, but it will still print is odd because it falls after the block. This would be the correct way of writing the code. You will check if the number is odd. In that case, you print the number and you also print is odd. You could have done this in one line, but this is just to show you the difference between writing like where the statements need to be placed for them to work with the block. So you need to always put them between the two braces. Only then will the system know that, okay, these lines belong to if. Okay, so this is the correct one. Now, so far you've seen conditions for numbers where we're comparing two numbers, but here we have a condition for we have a situation where we want to compare strings, and like we said, strings are nothing but bunch of characters put together. How can you compare strings? This can be let's say a useful thing when you are comparing username and password. For example, if you're trying to log in, you provide your username and password, and both of them are characters. So in order for it to work, in order for you to validate if they're correct or not, you have to compare them. And the problem with string is you cannot write, for example, the string object here, for me it's called choice. So if I write choice equal to, and then check if it is the same as yes, this is more difficult than it looks. Yes, this is wrong. This is not the correct way of checking strings. Okay, the correct way is to use equals ignore case, okay, or to use equals dot equals. There are two methods that belong to the string class. The first one is equals ignore case, and the second one is equals. And then you put the value that you want to check within the brackets. The difference between the two is here in the first one the case doesn't matter. So even if the user entered capital Y, capital E, capital S, as long as the word is the same as the one that you're checking it with, it will give you true. But with equals, it must be written the same exact way that you have mentioned here. So for example, if everything is small letter here, I must have the same word with the same case in the one that I'm checking it against. Okay, this method is useful for checking passwords, because when you write a password, even the case needs to be the same. If the case is different but the word is the same, even that is not correct. Okay, but if you want to ignore case, you don't want it to check the case, you only want it to make sure that the word is the same, then in that case you can use equals ignore case. Okay, there's another way of checking boolean in if conditions. Booleans are basically variables that store false or true. They have both true or false values. So they already have an answer, true or false. So you can put them directly in an if statement to build a selection. So if the value of the married is true, it will print this. If it's false, then it will print the other statement. Now finally, for floating values, what happens, floating values meaning the values that have decimal numbers with, like in the number itself. So for example, if you have 18, F1 for example, here is 18.00001, and F2 is the same number, 18.00000, let's say 2. I'm not making it the exact number, but anyway, for the most part this number is correct. The only difference is at the very, let's say, end of the digits, right? So because of this little difference, the two numbers will not be considered the same, only because of that ending digit. So what can be done to consider if two of the numbers are almost the same? Let's say we don't want to look at all the precision, we just want to make sure that for the most part the number is the same. What you can do is you can subtract these two numbers, and if the difference is smaller than this number, for example, you can consider them equal to. This can be any number of your choice, as long as you want, like, how close you want the difference to be. So this is just for your information, that if you want to make sure that two floating values are the same and they're only different in the last, let's say, numbers, you can subtract them, and then whatever the difference is, if it's very small, like the number that is written there here, then you can just consider them equal. Okay. Now, multiple conditions. One example of where you must have seen multiple conditions is, so far we finished one-way selection, two-way selection, and the last one was multiple conditions or multiple selection. In situations where, let's say, you call someplace and the operator is now speaking, and it's giving you the options to open an account, press 1, to query an existing account, press 2, press 3 for a specific action, and press 4 for another action. These are situations where multiple conditions are involved. This is how the multiple conditions for cascaded if looks like. Very important, can be a question in the exam. It's cascaded, CASCADED. Cascaded if. Cascaded if is when you have a condition, okay, you have multiple conditions, right? But the first condition, or let's say the second condition, basically falls under the false branch of the first condition. And you can notice that in the next condition as well. The third condition falls under the false branch of the second condition. That is what cascaded if is. Very important, because there's another kind of multiple conditions, which is nested if, and it's very similar but has a very small difference. This is what cascaded if looks like in code. For example, let's say you're taking input from the user, okay, and the user gave you the input 3. Now you're going to check if, and the 3 value is stored in option here, okay. So now you're going to check, is option 1? No, so it will skip this one. Is option 2? No, again it will skip this one. And is option 3? Yes, so it will print, enter password, and then it will skip everything after this, okay. Now let's say the option was 13. In that case, it will go through this. It's not 13, so skip this. It's not 2, skip this. It's not 3, skip this. It's not 4, skip this. Now all the options are skipped, and it reaches the else part, which is it didn't find any option. So in that case, it will just print wrong choice. Okay, so else is executed if none of the conditions match, okay. And it's very similar to if else, but the only thing is you have multiple conditions in between, okay. And all of the multiple conditions in between are always written as else if. So else, and then you put another condition, else another condition, else another condition, and finally you need to have an else, okay, which will work if none of the conditions match. This is an example of cascaded if. Okay, now all of these operators, they allow you to make conditions. We've spoken about them, and these are this is the precedence. The first one, the first priority is for brackets. The second priority is for not. The third priority is for all the comparison operators, then all the equality operators, and then finally or. Okay, and this is an example here. So for example, if car is cheap and car is in good condition, then you buy the car. Otherwise, forget it. But if car is cheap or the car is in good condition, better not take a chance, which is buy the car, and then forget it, or otherwise forget it. And this is pseudocode. You don't actually write it like this. This is just for you to explain. Okay, again, we've seen this. This is two-way selection, and when you put and, it will basically, we said if both the conditions are true, only then it goes to the true block, otherwise it goes to the false block. This is something called the truth table. It allows you to figure out what will be the result of two conditions when you join them using and or the or operator. So like I've mentioned before, if both the conditions are true, only then the final condition will be true. If either of the conditions are false, the final is false. Again, either of the condition is false, it will be false. Both the conditions are false, it will be false. Similarly, you can find out for x or y. Okay, if both of them are true, then it will be true. If one of them is true, it will be true. If one of them again true, it will be true. And then both of them are false, so it will be false. So if you notice, and gives you true if both of them are true. Okay, if both of the conditions are true. Or gives you false if both of the conditions are false. Otherwise, it will be false for and true for or. We've just mentioned that. And the not operator here, so for example, the result of x is true. If I put not before it, it changes it to false. If it was false, it will change it to true. Okay, and again, we can go through this. It's the same thing. For example, enter price. Let's say for price, it should have been number, but just for you to make it for you to easily understand this. If let's say the price was cheap and the condition was good. So if price equals ignore case is cheap. Right now in price I have cheap, so that is true. This part is true. And then condition is good. So in condition I said we have good right now, so this is also true. And because you have and here, true and true makes the whole condition true, so this will be the correct statement to be printed. If you have or and the same case, cheap, okay, and then the other one is good, I will just write G for the next one because this takes too much time. Okay, let's suppose price is cheap, condition is good, or condition is, let's say, bad, just for you to understand. So condition is bad. So price is cheap, this is true. Condition is good, no, this is false because we said condition is bad. And because you have or in the middle, one of them is true, so better not to take a chance. And finally, now if this was cheap and this was good, then this is true, this is true, and because of and, the whole thing is true. But if you notice closely, at the end we have, or in the beginning, sorry, we have not. So because the whole condition is true and we have a not here, the condition, final condition becomes false, and the correct print statement would be buy the car. Okay, now the next one we have, the first multiple condition we saw was cascaded if. The next one that we have is nested if. And nested if looks something like this. You have an if condition, and within the brackets of that if condition, you have another if condition. Okay, and within this one, you can have another if condition. So that's why it's called nested, because it's one within the other. Okay, and this is how it looks. Now, the only difference between this one and cascaded one is the condition, the second condition, falls on the true branch of the first condition. For cascaded, the second condition or every other condition falls on the false side of the previous condition. For nested, every condition falls on the true branch of the previous condition. This could be a question in your exam. You will be given different flow charts and you need to figure out if it's nested or cascaded. And this is another example for the program flow. For example, if the PIN is correct, then you're checking if the amount that the user wants is less than their balance. So you have a condition within the true side of the previous condition. And in code, it looks like this, like I've mentioned before. If you have an if condition, and these are the brackets for this if condition, Within these brackets you have another if condition, and these are the brackets for this particular if condition. Okay, now the last thing is the switch statement, and this works for cascaded if statement, the one where we write if, else if, and else. Now if you notice, on every if statement you have the word choice, not word, sorry, variable choice. So you have you've repeated that word 3 times. Now you can write a switch statement, which makes it a little bit easier to write, and you need to mention the variable you're checking only once. So I would write the word switch and then the variable that I want to check, and all of these values 1, 2, and then 3, I need to check them in different cases. So 1, 2, and then 3. Okay, the else part is represented as default. Okay, so if none of these matches with the value stored in choice, then the default will be run. Now if the choice was 1, you print A. If the choice was 2, you print B. If the choice was 3, you print C. But the only difference you see here is the break. Every case has a break. Why do we have this? Is the break literally means if for example, if the choice was 1, okay, if the value in choice is 1, this is the first match, the only match honestly here, and so in that case the system will print A. But after it's done printing A, we want to tell it to go back, because if you don't have the word break, it will keep continuing. Okay, and we don't want that. We want it to go back once it finds a match. So that's the purpose of using a break. It's to return after a match is found. So every time you write case, you need to write whatever it needs to do, and then at the end of that case you need to write break. And this is how it looks like in code. We present the user with a choice, a menu basically, that from which they can choose. They give us their choice, we check which choice it is. So for example, if the value stored in menu choice variable, if it is 1, it will print you chose menu option 1, and with the break it will go back. If it was 2, it will print you chose menu option 2, and with the break it goes back. And with 3, if the option is 3, you chose menu option 3, with break it goes back. If none of the options, if the option that the user selected does not belong here, or it's not presented here, then it presents error invalid option. You can write a break here as well, but it's not required because there's nothing after default usually, so you can skip that break. Okay, now one thing to know about switch statements is it can only work with these types. So when you write whatever you write here should be of the type character, byte, short, or int. It cannot be float, it cannot be string, it cannot be anything else. And the comparison that you're going to do is always equality. You can't have greater than or equal to. You can't write menu choice is greater than 1. No, that doesn't work. You're always checking for equality. Whatever this variable is it equal to 1? Is it equal to 2? Is it equal to 3? That is what you can check. That's the limitation for switch. Okay, all right, that's it for this lesson. If you have any questions, let me know. But this is very important unit, because now every other unit will build upon this knowledge. By the next few chapters, it is essential that you know how to build conditions and you know how to write if statements. And yeah, and the lab will help you practice that. So make sure to work on the lab. And like I've mentioned before, you can now repeat the labs as many times as you want, but your first attempt will be your final score for the lab. But other than that, you can practice it as many times. And my recommendation for the exam is that you actually practice the labs multiple times, because majority of the questions that will come in your exam will be from the lab. Okay, all right, have a good day, see you next time.